It is a strange thought. A place defined by its lack of water, a vast expanse of sun-baked sand and rock, is among the world's most intensive users of it. The desert seems an unlikely stage for such a story. Here, life has adapted over millennia to survive on the smallest of sips. Camels can go for weeks without a drink. Tiny insects draw moisture from the morning fog. Plants have roots that delve deep into the earth. Yet, modern human settlements in these arid lands tell a very different tale. One of extravagant consumption. We see cities of glass and steel rise from the dunes. We see lush green parks, sprawling agricultural fields. This transformation is a marvel of human ingenuity, but it comes at a tremendous cost. To support these oases of modernity, water must be found where there is none. It must be created, moved, and managed on an epic scale. For a kingdom like Saudi Arabia, flanked by the Red Sea and the Persian Gulf, the answer lies just offshore. The oceans hold the promise of life-giving water for those with the technology to unlock it. But this solution creates a new and unexpected problem. Why would a nation bury saltwater? It is a question that seems to defy logic. Saudi Arabia is one of the driest countries on Earth. It has no permanent rivers or lakes. Rainfall is scarce and fleeting. For centuries, life was sustained by scattered oases and deep wells, tapping into ancient underground aquifers. The discovery of oil provided the wealth and technology to drill deep and pump this fossil water to the surface, fueling an agricultural boom and urban expansion. But this solution was temporary. The underground aquifers were not being replenished. Once pumped, the water was gone forever. And so, Saudi Arabia turned to the sea. With over 2,600 kilometers of coastline, the nation had access to a virtually limitless supply of salt water. This led to a massive investment in desalination. Saudi Arabia is now the world's largest producer of desalinated water. The desalination process splits seawater into two streams. One is precious fresh water, the other is what's left behind, highly concentrated brine. This brine contains all the salts that were removed. It's significantly saltier than normal seawater, a waste product created in immense quantities every single day. The process of turning the undrinkable sea into life-giving freshwater feels like modern alchemy. Powerful pumps push seawater against special membranes with microscopic pores. These membranes let water molecules pass through but block the larger salt molecules. The result is a division. Pure fresh water on one side, concentrated brine on the other. Many coastal plants simply discharge the brine back into the ocean. Because it's much saltier and denser than seawater, it sinks to the seabed, creating an oxygen-depleted layer. For Saudi Arabia, with fragile ecosystems like the Red Sea's coral reefs, this is a major concern. The Red Sea is a global treasure teeming with unique marine life. This plume of hypersaline water can be devastating to local marine ecosystems. Coral reefs, seagrass beds, and other sensitive coastal habitats can be severely damaged. In the enclosed, shallow waters of the Persian Gulf, the problem is even worse. Limited water circulation lets discharged brine build up over time. Decision-makers face a stark choice: a constant flow of waste that must be disposed of, or a disposal method that threatens natural resources. That dilemma has pushed engineers to seek alternatives. That search leads away from the coast and deep into the desert, to the surprising practice of saltwater burial. Deep well injection involves drilling extremely deep wells, often thousands of feet down, into porous geological formations beneath the Earth's surface. The brine is pumped under high pressure down these wells into saline aquifers, underground layers that already contain non-potable salty water. The idea is to lock the waste product away deep underground, where it's isolated from drinking water supplies and the surface environment. It requires a deep understanding of the local geology to ensure the brine remains safely contained. There are risks involved. The high-pressure injection could potentially fracture the sealing rock layers, allowing the brine to escape. The long-term effects are not fully understood. It is a strategy of containment rather than treatment, a way of hiding the problem deep beneath the desert sands. Scientists are now exploring ways to treat brine not as waste, but as a resource. Advanced technologies could extract remaining fresh water and harvest valuable salts and minerals. This concept, known as zero liquid discharge, aims to create a closed-loop system, turning a costly disposal problem into a profitable new industry. The story of Saudi Arabia's saltwater burial is a glimpse into the future of water. We must move from a linear model of take, make, dispose, to a circular one of reuse, recycle, replenish. The challenge is to find solutions that work in harmony with the planet's systems, rather than simply hiding our problems deep beneath the sand.